Friends, sometimes you make a project and you publish it, but it has some problems. So you fix the problems. What now? Do you manually tag it as v1.01? Ugh. No. We have PageKey Semver for that. It's written from scratch. It's simple to use. Does it have every single feature known to man? No. But less features means less bugs, right? And you can't beat how easy it is to get started. So with that, let's check it out. So we're talking about PageKey Semver, simple opinionated semantic versioning. Now, what is Semver? We'll talk about that first. We'll talk about how to use this thing, how to configure it. We'll go on a little code tour and talk about next steps. So Semver in 30 seconds, if you're not familiar, there's a ton of information on semver.org. But in short, practically speaking, you're just prefixing your Git commits in order to trigger new releases, and you use special types of prefixes to indicate what type of release it is. It's a major release if your code will break when you update. In other words, if your package that other people are using is going to break as a result of these changes and they have to change their code in order to keep using it, that's a major change. Similarly, minor is when you add a new feature, but there is backwards compatibility. So they get the new features, they can use them if they want to, but their old code will continue to function without modification. So that's going to go from the middle number is going to increase to 1.1. The old one, you'll see that the leftmost number is the most important, the most major, and that's what increases. So with those two, what's the third one called? It's a patch. It's just fixing little bugs and things here and there. Doesn't really change the API, the amount of features available to the user, but you're fixing things that might have broken. So let's say you have a simple little Git project and all you did was make the initial commit in which you touched readme.md and everything's fine. You pushed everything to your remote. Now you're going to do some work and we're going to say that we're going to make a little bug fix. So we'll just create a file called bug fix. We'll add it to Git and then we can do git status. We'll commit it and we'll say fix squash a bug. So that's in our commit log, and now we just have to do pip install PageKey Semver. I'm not going to run that because I already have it, but then you do PageKey Semver plan. It picks up that you had a fix in there, but we haven't made any versions yet, so the first one is always going to be 010. So we'll just do apply, and now we have a git tag for 010, and it has been pushed to our remote. And if we check which changes were made, the only thing that happened was it created a changelog. So if we cat changelog, there it is. Now, what happens if we make another fix? So if we add it and commit it and we say fix, another quick fix, and then we run PageKey Semver apply, it has tagged 011, our changelog is updated, and everything's been pushed. I think even the tags. Yep, everything's up to date. So, quick and easy. Now, what if we do a minor tag? Let's touch a minor thing, and we're going to say minor, add new feature, and we'll do PageKey Semver apply yet again. Now it's 020. There it is. Git tag, changelog, all done. So we just added our new feature. Now what if we break something? So we're going to remove another fix. We're going to remove bug fix. We're going to remove minor. Yes. We're going to say major, remove, all kinds of good stuff. So that's our commit. We run PageKey Semver apply, and we end up with a tag 100. So we've incremented that first number. It's version 1. And we're ready to roll. Now some people like to use these as major versions in the 0. Releases. You're welcome to do that, but it doesn't change the logic of how this scans for commits. So you better be using feature commits before you get to 1. Anyway, that's it. So that's a local demo. Let's talk about everything else. We don't want people running this locally. We want this to be done by machines because humans, when they run this sort of thing, make mistakes and forget things. So instead, let's set it up for GitHub Actions. It'll run in CI/CD on some faraway server in GitHub headquarters, and you don't have to worry about it. So to do that, I'm exporting these as bash variables, but really you need to go into your repo settings or organization settings and set these as secrets. But you do need to set these too. So you'll set the Semver user to your username, and you'll set Semver token to your personal access token, your little pat. or you can try using OAuth2 as the username and use the built-in GitHub token credential that is provided to, I think, every job. And then you can just copy this little block of code verbatim and paste it right into .github/workflow/ci.yaml, commit that to Git, push it, and you should see GitHub Actions running. And you can debug, because everyone knows CI/CD does not work on the first try. So good luck. Now, if you want to run jobs on release, so when new tags are created for GitHub, then you can use this little snippet. So you have to set it to need that version job we just created, and then you can use this if statement to filter only when new tags have been created will these steps run. So this is great for pushing something to PyPy or to any other package registry, whatever you need to do only on tags. So for example, you check out the code and then you do other stuff after it. Now, how do we do this on GitLab? Well, it's very similar. You have to set up Semver user and Semver token credentials. Again, you can use your username or a personal access token, but GitHub makes it a little easier because they give you access to CI user and CI token in every single job. You just have to keep in mind that these will have the permissions of whoever triggered the pipeline. So they might not have permission to do Semver stuff. So you got to be cautious there. But to go get started with this, you just need to copy and paste this snippet, paste it in, commit it, and push it, see what happens. It just has a version stage and 2 jobs, one for the dry run with the plan, one for the actual with the apply. And notice how the dry run runs just about everywhere except for main and tags because it's not necessary. And then the actual one runs only on main because that's the real deal. It's actually going to make a git tag and push it. And GitLab, if you want to run jobs only when releases have been created, it's a lot simpler. GitHub makes it hard to run things on automatically pushed tags because they want to prevent infinite loops, but GitLab doesn't do that. So you can just say only on tags and you're good to go. Or if you want to be fancy and use rules, which only is actually deprecated, so you probably do want to use rules, you can go ahead and use this syntax. So what if you want to change things? Well, plenty of configuration options for this package. It's easy, just create a .semver file in the root of your repository and you get access to all of these options. Look how many there are. It's wonderful, wonderful, wonderful. Let's go through all of them. So before we do that though, environment variable override is possible. So if you want to override any of these settings we're about to talk about, just keep in mind that you can use a Semver prefix and set environment variables to override pieces of things. You just use the whatever key it is, and then double underscore to go down one more key, and then double underscore again to go down another key. So you just reach into the config in that manner, and you can change things with environment variables on the fly, which can be very convenient. Also notice how some of them, file replacers, for example, is a list. If it's a list of things, you just need to assign an arbitrary key to that list item. And then this is basically discarded. It's just used to tie these fields together into a single object. So very flexible environment override. Now let's talk about the individual config options. There is tag format. So if you want to change the tag format, %M is the major version, %m is the minor, and then %p is the patch. So you can use that templating syntax to create whatever. So if you want v1.0.0, that's the default, you use that. If you don't like the v, you can override it like that. If you want to come up with some kind of crazy syntax like mage, min, patch, whatever, you can do it. Just specify format in your .semver file. If you want to change the changelog path, it's very similar. It's super easy. Just change the changelog path, and then that's it. Now prefixes. If you override the prefixes list, you will lose the default ones, major, minor, patch, fix, all that stuff, but you can create your own. So if you want huge : to indicate a major release, mini : to be minor, and micro : to be patch, you can do that. Nothing's stopping you. And you can have as many of these as you want. So if you want docs, if you want CI, if you want all sorts of other scoped tags and things like that, go for it. It doesn't have support for putting things in parentheses, but you can add each individual thing in parentheses as a prefix. File replacers. So these allow you to replace files when the new release is created. It does this alongside creating the new changelog, and then creates a git commit that gets pushed with your Semver user and token credentials. So by default, there's nothing, but if you want to replace a key inside of a JSON file, for example, package.json is a common use case, then you just specify that you would like to change the version key in there. You specify the format that you want it to have after the replace takes place, and then you can see what happens. Our JSON file on the left here, prior, it doesn't matter what it's set to, and then afterwards it gets rewritten to have that v100 tag, which is really nice. TOML, very similar. If you have a TOML file, then you can replace the version key with whatever format on new tags. Notice that we can do nested keys, so project.metadata.version, it's fine to reach all the way into the file as deep as you need to. Same for YAML, exactly the same, just in YAML format this time. So you can see that you can replace the version inside of a YAML file too. Now, what if none of those fit for you, for your specific situation? Well, sed should just about cover the rest of it. So you can use the Linux sed tool to specify a script to do a replacement, and you can use that mmp templating to get that done. So if you specify this script, any lines starting with this will be replaced with this is version major minor patch of the project. So if we run that and it's version 1.0.0, you will see this file get replaced and turned into this file. Changelog writer. So what if you don't like the syntax for the default changelog writer? You can of course change that by defining in a .py file your changelog writer custom class that just has to extend from the changelog writer interface in the PageKey Semver package, and you just have to implement one method, which is write changelog. This gives you a changelog file handle, a version, which has a name and some other fields that I forget, and commits, which is all of the commits in that release. So in this case, if you want to just say hello to the version and then have a list of or whatever this is, tilde in front of each commit message, you can do that and you will see this result. But you just have to specify the path to the changelog writer as a Python import, and then the colon indicates inside of that module. So if it's like com.mypackage, you would do that, and then colon indicates whatever inside that file you want to import, and it dynamically imports it for you. GitHub release creator. So this is an integration with GitHub. All it does is send a post request on your behalf when the new release is created. So you specify the project, the token variable you'd like to use for doing the git push. So that's used for HTTPS git push. So this variable should contain whatever credentials. And then the title format is just what you want the title of the release to be. You can use the templating there. Body, you can't really use templating here yet. More to come on that, but that's basically all there's to it. What if you want to use it on GitLab? You can do the same thing, but you have to specify the project ID. Now, if you want to override and just set that automatically, CI project ID is set for every job, so you can just set this variable and do the override. Actually, there's a typo. Notice the double underscores in between fields because some of these fields have underscores in them. So how else can you tell it apart? So we have our Semver prefix, integrations. We reach into the GitLab section. We reach into the create release section. And then we want to change the project variable. So we set that to the CI project ID. So that should be all you need to create GitLab releases. And that's it for configuration. Now, I'm sure the moment you've been waiting for is the code tour. What's there to say here? Well, I've been trying to do solid principles. All right, fair. Tried to do test-driven development. You'll see that. Still a little messy, but it works. I'd love to consolidate the CLI and Git Manager. There's still some code debt floating around, but you'll see that it works well enough. So what are the high-level steps you'll see in the code? Parse the CLI args, do some GitLab magic. You get all the tags and find the largest prefix among them. And then you get commits since the last release. And then you compute the release type based on those commits. So are we about to create a major, a minor, or a patch? Then you compute the next version using the output of step 3 here because you have the largest tag, and then you just need to increment either the first, middle, or last number based on the release type. And then only when doing a non-dry run, now you know what should be done, then you actually create the tag and push it to GitHub and send that post request to create a release on GitHub or GitLab if it's enabled. So what classes are there to make this happen? So the CLI area module, whatever, is just parsing the config args, whatever. There are some Git classes, an effector and a querier separately to just make changes in a Git repository. They both use just Git commands under the hood, but tried to abstract them a little bit to hide those details away. Semver release contains all the logic for computing releases based on prefixes. Changelog writer is the base class for any changelog writing that goes on, and then it lets you extend it to make your own. File replacer, self-explanatory, supports JSON, TOML, YAML, and sed. And then config just loads the config. Models is just data types. So we're right here on GitHub. Where to start? Why don't we start with the tests, because they really drove the development. I couldn't have done this without writing a whole bunch of tests. So everything is test first, red, green, whatever. Write the test before you actually write the code. Lots of unit tests, and then integration tests were also essential here. So every integration test sets up a little Git repo in a temp directory somewhere on your system, and then each little use case is kind of outlined in comments, and then it actually does those things. So it sets up the Git repo by making commits and things to get it in a certain state. It runs PageKey Semver apply using the CLI entry point function. So essentially the same as invoking it on the command line, and then just make assertions on which files should be where and what changes should have occurred to the Git repo, which tags exist, things like that. So there's a bunch of these, and they were pretty essential. Yeah, so the tests were pretty important. Now in the source, what do we have here? Well, we have changelog writer, which just has a base class with some helper stuff, and then the default, which just writes a header 2 for the version name, and then little bullet points for each commit message. And then this takes care of just setting up the temporary file and doing replacements and things like that. So nothing crazy there. CLI.py is where all the action really happens, where we parse our CLI args using argparse, and then we set up all these little helper classes that we're going to talk more about. There's a GitLab hack that just kind of snuck in here. I had to check out and fetch tags and all that different stuff. And then the manager gets the Git tags, and then this looks a lot like that slide explaining the big high-level steps. From the tags, it finds the largest tag, gets the commit messages since the last release, computes the release type, and then computes the released version given that computed release type and all of the tags. At that point, it can tell you what the next version is, and if there is a new version. In other words, if there's a new tag that would be created, it's not equal to a tag that already exists, basically. If it is equal, then, there's nothing to do. So you just write nothing. And then all these little GitHub output options are just signaling a GitHub output, so we can use that if statement to determine if a release happened and run special commands based on that. So nothing crazy there. And then if we actually have a version to do and we're not doing a dry run, then we need to apply the version. So we're going to update the changelog file. We're going to run all the file replacers, and then we're going to apply tag, which does a git commit, creates a tag, and then pushes it all in one function, which is a little messy. And then we set a GitHub output to indicate that a release did occur. Then we run our release integrations. So these are going to create GitHub and GitLab releases respectively with a little post request. And if we're in dry run mode, we just print what we would have done, and then we say that a release did not occur. So that's basically the whole flow of this program. And we can dive into the nitty-gritty details of these real quick for anyone who cares. Probably nobody. But config just contains Pydantic models for all of these things. So the Semver file, as well as all other configs, are right here. And then the the load config function is first checking if the .semver file exists, parses that, and then it gets all of the config items from the environment, and then it merges those two dictionaries. So you'll notice that the original config from the file is first, and then the environment second, because the environment takes precedence over it. So we're going to override the file with anything that came out of the environment. Models contains all the fun data classes and things throughout the repo. So we have a git config and prefix and other things like that. Commit, tag. These are pretty boring. Not much to talk about here. In release, there is a Semver release class. There's also a way to check if releases are greater given two release types. There's a no release, a patch, minor, or major release type. And Semver release can compute the release type, get the matching tags for a release, get the biggest tag, compute the next version. All those details are here. It's not that long. And you saw that used earlier. How do the file replacers look? Well, the top level is just an interface. It looks pretty boring. You can just perform the replace, right? So JSON, how does it do that? Well, JSON opens the file, replaces the major minor patch, sets the dict value with that new version string within the dictionary of the parse JSON file, and then it just dumps that dictionary back into a JSON file, and it pretty prints it too. So that's JSON. Toml and YAML are basically the exact same thing, except they're parsing in Toml or YAML syntax respectively. Nothing big there. Now, how does sed work? Sed is nothing crazy. It's actually just parsing everything and creating the script. It's doing the replacement for the major minor patch in that little script you specified, and then it runs the sed executable with that script. That's the file replacers. How does Git look? Well, Git Manager is messy and not as well tested as it could be, because it contains this apply tag thing, which basically sets user.email, adds all, creates commit, creates a tag, pushes it, and then resets the user and email back to normal, and also messes with the remote URL, all that different stuff. and then you can set the Git remote. This is kind of complicated to figure out how to push it. It does like HTTPS based on which credentials are provided and does all kinds of crazy replacements and things. This was pretty well unit tested because it was just a complicated thing to do. Effector for Git is very simple. It's just, what Git things would we like to do at a very low atomic level? And then using commands to make those manipulations to the Git repository, we have git config, git add all. These should all look familiar. Same thing for the querier. This is just getting information from Git using Git commands and returning them in a nice Python data format. So we're running git tag, git config, and commits and things like that. Just getting information from Git, nothing crazy. And then release creator creates releases. And you can see that it's posting to an API for GitHub, and it's posting to an API for GitLab, just taking all of that information out of the release config that it parsed from the file in the environment, and making those requests. Now, util, some fun stuff in here. Command runner. This is just a nice wrapper around sub-process so that we know exactly what's going in and what's going out, and does some checks on the error code, other things like that. This really just made testing much easier. You can use dependency injection to inject a command runner instead of trying to patch sub-process all over the place. And you get some nice human readable error messages that way too. So that was nice. Dynamic import just uses import lib to take a string, which is the string that is used by the changelog importer. So directly takes that string and it imports that module, reaches into the module and gets whatever class represents your changelog writer and then returns it. So that's all good. And then converting env to dict. So this basically just takes all environment variables as a dict of strings to strings, and then finds that prefix, strips it out, and then returns the value of those as a dictionary, I believe. And then that can be used as a Semver config object, which we saw over here. So it just conforms it to a dictionary like that guy, and it can be turned into it, and you're good to go. So that's env to dict. Update dict, I will admit I had some help from ChatGPT on this one for writing these because they're just, pretty generic, getting dict values and other stuff. So the path is obviously just like x.y.z to reach into the dictionary, and then merging these dictionaries, pretty self-explanatory. It's recursive. It's not like overwriting things. It does a nice job of dynamically merging them, whatever. So that's actually the entire code base. Probably more than anyone ever wanted to know about this, but there you go. So what's next? I'm going to start using this on all the PageKey projects. If it breaks, I'll fix it, and then I'll repeat, and hopefully it'll result in a nice, high-quality, useful product that anyone can use. The first thing I want to change is writing the same content that I'm writing to the changelog to the body of the GitHub GitLab release, because it looks kind of weird just having a static body. It would be nice to see those changes in the body of the release. Anyway, that's it. Hope this was helpful or interesting or useful in some way. Thank you for watching. See you later.